not sure of a name I'm going to call this, but the topic is natural selection and what biology is, and my new book on biosense, biological common sense. The issue is the only difference between chemistry and biology is natural selection. And there's two things fascinating about natural selection. One of them is it's the most creative thing we know in the universe. It probably created life itself, and then it created life forms. And not only that, but we have natural selection embedding, recursive natural selection, in that we have natural selection that created life, and inside that, it created natural selection among life forms, which created new forms of life. And then those living creatures have natural selection immune systems inside of them, and natural selection competitions among thoughts in brains and neuron systems inside of them. So you've got natural selection system in natural selection system in natural selection system, at least 3 layers deep. And that's a very fascinating thing. Number two, if you look at natural selection, it's not a system that optimizes fitness. And Michaud's book is probably the simplest summary of all of that, although Kimura did the main research on that in terms of the neutral drift theory, which opened the door to the fact that natural selection did something other than optimize fitness. And you can understand this even in a common sense way. If the fittest to the present environment thrives and drives out all other forms, that's great if the environment shifts a little and gradually and slowly. But if there's a big shift in environment, then this thing so terribly optimized, so well optimized for the present situation just dies. And Danny Miller wrote an article about this called Success Always Fails in the business and economic context, that corporations that were superbly optimized, like IBM was for the mainframe era, die or nearly die when the environment changes and people want PCs instead of mainframes. Because everything in IBM followed what worked, copied what worked internally, and that was mainframe stuff that worked, and all the people were mainframey, all the systems were mainframey, all the ideas and plans and imaginations were mainframey. And when the environment wanted something else, there was nobody in IBM who could think or see or feel or talk or do or plan or develop or enthuse for the new stuff. So natural selection optimizes something other than fitness. It's not the fittest for the present environment that survive. It's the fit for the present environment that has the largest library of unused neutral traits. And when a big shift in the environment occurs, there's a ratio of some of those neutral traits are no longer neutral. And some of them will turn out to be harmful in the new environment. Some of them will turn out to be beneficial. And there'll be a ratio. And if the ratio overall is beneficial, and none of the harmful ones are fatal in the new environment, then it'll thrive in the new environment. So it's the entity with the largest repertoire of neutral in the present environment traits. Think about an employee or a manager or a leader in a company who is fit for the present environment but not optimal for the present environment, and who maintains a huge repertoire of capabilities unused in the that's going to make your company survive. The more such people you have, the more likely it is when the environment shifts greatly, the ratio among them is likely to be enough positive that you can survive. If there are not any of them at all because you're so optimized for the present environment, you'll just die because there won't be any way to respond. Nobody will be capable of responding. So this is common sense in biology. And it's not what they teach. It's not, folk ideas of natural selection. And so what does natural selection optimize? It's not the optimized creature that survives. I've already made that argument. So what does thrive? What does natural selection generate? It doesn't generate the fittest creature for the present environment. It generates new, higher, more abstract levels of organization that lowers the fitness of basic units by evolving a higher interaction among those units, and the power of that higher coordinated interaction among those units gradually entifies, becomes an entity. And that is fit enough, made fitter to survive, at the cost of making the individual entities within it not as fit as they were before the larger scale thing emerged. It's like a cooperative pattern among bacteria, so that one bacteria, if it lives next to another bacteria that makes energy, can borrow some of the energy products of that bacteria, which if it lives next to a bacteria that uh, uh, eliminates waste from the environment without an energy expenditure, the three of them can live together better than any of them can live alone. And then eventually a membrane may form around the three, and they become parts of one cellular entity. This is exactly one of the 7 levels of organization in the origin of life that actually occurred in history. Mitochondria being the most obvious example of a bacteria that was around and then got incorporated inside as for a special function of being an energy machine inside ordinary cells. But originally it was a bacterium outside. And so this is the evolution of higher, more abstract levels of, entity, of organization they're the higher level as fitness properties for the present environment and power that are earned at the cost of reducing slightly the fitness of the individuals to live alone, should the entity break up. Now, what can you and I do? Well, technologies, to a certain extent, have a natural selection process among them, and hit songs, to a certain extent, have a natural selection process among them. And prices of art objects in auctions have a certain natural selection process among them. And ideas in brains or in discussions in conferences or in academic fields have some natural selection processes among them. Or Panksepp and Edelman suggest that even thoughts in brains have a natural selection competition going on among them and evolution among them. The issue is how much of biological natural selection dynamics should we try to carry over into the analogy on other substrates. The artificial life people who are trying to create living forms and conscious forms in computers are really useful people because it's like experimental philosophy. They are actually seeing if what we think life is can be made in other substrates, and therefore it'll help define biologically what's essential and not essential, what's central, what's peripheral in the idea of life and the idea of organism and the idea of consciousness. How can you use this? Well, first of all, you'll get nowhere with the folk idea of variation, combination, selection, and reproduction, the old Darwinian idea of natural selection. That's crap. Optimizing fitness isn't in there. It can happen, but it's a rare parameter setting. So it's not really part of the system as it actually operates. Kimura is the beginning of the post-Darwinian image of natural selection. You can read him if you want to read the original Nobel Prize articles for his work. But you have to get rid of that folk image, first of all. Number two, you're going to have to be perspicacious and honest about what parts of biological natural selection you keep and apply to technologies as a substrate, or to natural languages evolving against each other as a substrate, or to ideas in brains evolving against each other as a substrate. You're going to have to be clear, because we don't fully understand biological natural selection yet. And as soon as you try to really be clear about understanding it and not just bandy about words somebody else defined that you don't really understand, as soon as you try to talk clearly about it, you'll find out it is very deep stuff, very sophisticated stuff, amazing stuff. And we understand just a little bit of it. And so being clear of what your model of it is has to be done, number one, so that you can see new developments and how they invalidate parts of that model. For example, Lamarckian inheritance, organisms inheriting genetically what they learned from experiences. That was considered for 100 years not to occur. Recent research shows that it does occur. The Crick and Watson model of DNA as the primary carrier of genetic and inherited information turns out to be a gross exaggeration. There seem to be at least two, maybe three systems beyond DNA that can inherit and bring uh, coded information into new organisms. So, you know, you have to be clear of what you think biologic natural selection is, and then you want to apply it to another substrate with your eyes open that further developments in biology may show parts of your model to be invalid, and that you may have chosen a subset of biological natural selection that leaves out an important biological dynamic which really works well in natural language evolution or thoughts and brains evolution or these other substrates. So the two things to be clear of is future developments in biology invalidating part of your model, and this issue of which parts of your model, what does your model have to include in order to work well when you apply it to a new substrate.